Use the given data values, a sample of female arm circumferences in centimeters, to identify the corresponding z-scores that are used for a normal quantile plot. Then identify the coordinates of each point in the normal quantile plot. Construct the normal quantile plot and then determine whether the data appear to be from a population with a normal distribution. So we want to list the z-scores for the normal quantile plot, and it says we need to round them to 2 decimal places as needed and use in ascending order, going from least to greatest. So what we're going to do is we're going to open up this data in a StatCrunch. Okay. Now, when we open up this data, we want to call this data the column. We're going to call these the x value. Okay. And so now we're going to go ahead and go to Stat, and then Graph, and then scroll all the way down the QQ plot. We're going to select x value, but then we want to make sure that the normal quantiles, meaning the z-scores, are going to be on the y-axis. So let's go ahead and do that. I'm going to go ahead and do that and then select Compute. Okay, now when we look at this graph, you're going to see the normal quantile plot. Now, recall here that the x value is located on the x-axis. Okay, and over here, the y value represents the z-scores. So if you click on that point, okay, you're going to see the following. Okay, when you highlight over that point, you're going to see that you have row 3. It says normal quantile is negative 0.967, and then below that you have the x value of 31.8. The normal quantile is the z-score, and we're going to round that to 2 decimal places. So the first one is negative 0.97. So therefore that represents the first z-score, negative 0.97. Okay, let's highlight again over this next z-score here. So the normal quantile plot, which is the z-score, is negative 0.43. So negative 0.43. Okay, next we're going to highlight over this point here, and that is the normal quantile z-score, which is 0. So that is 0. Okay, and then the next z-score we have right here. When we highlight that, we're going to see that it's 0.43. So we have 0.43. And then let's go ahead and highlight this last point, and the z-score there is 0.97 rounded to 2 decimal places. So we have 0.97. So again, that represents the z-scores. Let's go ahead and check our result, and there's our answer. Okay, now it says identify the coordinates of each point in the normal quantile plot. And so use ordered pairs for the form xy, where x is the sorted arm circumference in ascending order, and y is the corresponding z-score. Well, if you notice, we called the data x values. Let's go ahead and open that up. When we highlight that first point here, you're going to see that 31.8 is the x value, and we have negative 0.97. So that's 31.8. So we have the x value of 31.8, and then the z-score is the first z-score of negative 0.97. So negative 0.97. Okay, let me put that decimal in there. Okay, next. Okay, now we need to take a look at the next order pair. The next order pair has an x value of 34.3, and it's going to correspond to that z-score. So we have 34.3, and then negative 0.43. Okay. Okay, next, let's take a look at the next order pair. The next order pair, the x value is 38.6 and has a z-score of 0. So we have 38.6 and a z-score of 0. The next one has an order pair, x value is 40.1 and the z-score is 0.43. So we have 40.1 0.43 for the z-score. And then the last one should be an x value of 43.9 and a z-score of 0.97. So we have the following. We have 43.9 and a z-score of 0.97. Let's check our answer, and there's our result. Okay, now we want to construct the normal quantile plot, which we already have. So we want to compare this. So if you notice here, we go from 2 to -2. So let's go ahead and make sure our y-axis has a minimum of -2 and a maximum of +2. Okay, and then it goes from a minimum of 30 to 50 for the x-axis. So let's go the x-axis. You can see it goes a minimum of 30 and it has a maximum of 50, just so that our graphs are going to match exactly what we want to look at. So when we take a look at this graph, what's important here is to look at the general pattern of the points. We're not looking at the red line. So we need to find the points, because when we look at the graph, the red line is not going to match exactly what we're looking at. But we want to look at the general behavior of these points. Okay, so if we take a look at the first one, you can see that these points don't have the same behavior as these points. When you look at this one here, you can see that there's 2 points here, 2 points there, and there. This looks pretty similar to B. Okay, if we take a look at C, it's not. If we take a look at D, it's not. So even though that this point is right below that red line, we're not concerned about the red line. We're concerned about those points. So let's go ahead and then select our option for B and check our answer, and there is our result. Now the question says, do the data come from a normally distributed population? So our question is okay, do they or not? Do they kind of form close to the line here? Well, we're not going to say no, because these points are generally close to that line. So we're going to say yes, the points are evenly distributed above and below the mean, or we would say that yes, the pattern of the points is reasonably close to a straight line. So remember, we are concerned with the general trend of these points, okay, not the exact. So in this case here, we would say that these points are reasonably close to a straight line. Therefore, our answer is going to be